Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is good ranking. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. There are n contestants numbered 1 to n. Our task is to make them participate in some contest and then manipulate the ranking in a particular way. Now, in each contest or competition, the ranking of the contestants can be considered to be a permutation of the integer 1 to n. That is, there are no ties. Now, a contestant A is said to beat contestant B in a particular contest if A occurs earlier than B in a permutation that will denote the contest ranking. Now this should follow and should be the case for all the pairs. That is for each pair A and B where their value will be between 1 and n and they cannot be equal because there exist no ties. And there should exist at least one contest where A will beat B and this should happen for all the pairs of A and B. Now our task is to choose a number of ranking, let's say m, and then print m permutation, the ranking of each of the contests, and we can have at most 10 contests. So what our goal is that we can host at most 10 contests and we can decide what is going to be the ranking, that is a permutation of numbers 1 to n. We have to give the permutations in such a way that for all the pairs of number between 1 and n, there exists at least one contest where A will beat B, and that has to hold for all the pairs of A and B. That is, each contestant should defeat all the others, and this should be the case in at least one of the 10 contests. 10 is the maximum. We can choose from 1 to 10. It is up to us. So for the input format, we have a single integer n, and for the output format, first we'll output m, that is the number of contests that we are going to host. Then for each contest, in a single line, we will print n spaced integers, that will be the rankings. So for the constraints, the value of n, that is total number of contestants, will go from 3 to 250. Let's see some sample inputs. So for the first sample input, the value is 3, that is there are 3 contestants. Here what we have done is we have print 6, that is all the permutation of 1 to 3. With this, there will exist always a case where each number defeats some other. Let's see how we can approach the solution. So let's assume we are given this number n. So the very first permutation that anyone will think of is 1 to n. Let's do that. 1, 2, 3 till n. Now what is happening in this case? Here 1 appears at first. It means 1 will defeat all the other numbers that are behind it. That is 2, 3. All the other numbers are defeated. What else can we do? Similarly, here we can see that 2 is defeating everyone apart from 1. So let's say we print it in reverse. Now what? If I print n minus 1 till 1, what happens now? Now in this case, n is defeating everyone going from n minus 1 till 1. So this case has been reversed. So in this manner, what we have done is here 1 is defeating everyone and here no one. 1 is getting defeated by everyone. Similarly, here 2 is defeating everyone else apart from 1. Here 2 will be in this manner. Here 2 is getting defeated by everyone and 2 is only defeating 1. So you can see that they are complement to each other. They are completing themselves. So in this way, with just 2 permutations, we can make it so that our permutation ranking will hold the condition that for A and B, for every pair of A and B, there exists one contest, either of them, where A is less than B, therefore defeating all the other contestants. And this is our solution. Let's see how we can implement the solution in C++. So for each test case, what we have is we have the input of n. Once we have this, we know that with just 2 contests, we can solve the problem. So we first print 2, then we first print the permutation of 1 till n, going in the ascending order 1, 2, 3 till n. Then we print it in the descending order, going from n minus 1 till 1. And at the end, as you can see, I've got an AC in my C++ implementation. Let's see how we can do this in Python. Again, for each test case, we have n, then we print in ascending order and at the end in the descending order. And with this, we have EC in Python as well. So I hope you understood the problem, the approach, and how we can implement it in both C++ and Python. Have a very good day, and I'll see you in the next video.